So this is lesson number 91 in Algebra 1, and it is multiplicative property of inequality and spheres. Alright, so multiplicative property of equality isn't going to be too bad. At this point, when you have an equation like x plus 2 equals 3, you get rid of the 2 by subtracting it from both sides and get x equals 1. Okay? Talking about inequalities, it would be the same as x plus 2 is greater than 3. That's an inequality. It doesn't have an equal sign, it has an inequality sign. So in order to solve this, you do the exact same thing. You subtract 2, and you say that x is greater than 1. So that means the solution set isn't just x equals 1, it's any number that is greater than 1. Alright, so one of the things that we're going to do is we're going to specify the domain. We're going to specify what numbers we can put in there for x. So for example, the first 91.1 example says negative x is greater than or equal to 2, and the domain is a set of real numbers. That means any number in the whole history of the universe can be put in there for x. Suppose I should put a number there. Okay, so negative x is greater than or equal to 2. So we have a negative here. We don't want that. Remember what I said, if we want to change the negative, we just change it. We just have to change it everywhere else. So we put that on there. And when we change a negative in front of an x, we change it over here. So when you move a negative from here to here, the sign has to flip over. And then it says graph. So we're going to graph x is less than or equal to negative 2. And the way we graph that, because this equal sign is there, we draw a solid circle. If there was no equal sign right here, if this was just less than, then we wouldn't put the solid circle. But with the equal sign, we put the solid circle to show that it also includes the number 2. And then we graph all numbers that are less than negative 2. Less than negative 2 are all the numbers that go that way. And we're done. Okay, so let's keep going here. The next example is 4 minus x is less than or equal to 6, and the domain is integers. Those are little parentheses. Integers. Integers are the counting numbers. It's not the numbers in between 1, 2, 3, 4. It's just the 1, 2, 3, 4. Okay, so looking at this, and we have negative x. We're going to subtract 4 from both sides to get our x by itself. Now we did not move this negative sign over here, so the sign doesn't change. We just moved a number from there over to there by subtracting it. And because this is like a negative 1, and to get rid of that negative 1, we divide both sides by negative 1, which makes this x, which makes this negative 2. So again, what did I do? I moved this sign right here and moved it over here, didn't I? Alright, and since I did that, since I divided by a negative right here, you switch the sign. So it's the same thing I did with the last one, to switch the sign. I moved the negative or divided by the negative. So there's my answer. And I graph it like this. 1, 2, and it says that the equal sign is here, so the answer can be negative 2. And it says that x is greater than, so that means we go to the right. And we make a solid circle on each one of the numbers that is greater than negative 2. But we don't draw the solid line like this with an arrow because we're not interested in the numbers in between our counting numbers because it says integers up here. Alright, ready for 91.3. It says that negative 3x plus 4 is less than or equal to 13, and our domain, or the numbers that we have to choose from, are our real numbers, or are all the numbers. Okay, so let's look at this. We're going to first of all subtract 4 from both sides. So 4 minus 4. And that, we didn't change the sign because we subtracted 4. We didn't divide by 4. And we get that. Now we're going to divide by a negative. And when you divide by a negative, again, you flip the sign around. And we get that. So then we graph. And we're at 0. So 1, 2, 3. And it says it's greater than or equal to. So it's solid again. If it didn't have this equal to sign, it'd be open. And it says it's bigger. And there's my answer. Okay. So continuing on, that's it for that particular lesson. But let me show you one in the problem set that you have to do. It's in the practice, and it's letter B. They have 2 minus x is not equal to 1, and we're looking at the domain of integers. Alright, let's go ahead and do this. Subtract 2, subtract 2. Negative x is not less than 1 minus 2 is negative 1, and I can divide by a negative and divide by a negative. Or I can just say I'm going to change the sign of that, and so I have to change the sign of that, and I have to switch the sign around. Negative over negative is a positive. So what does this say? It says x is not greater than 1. So what does that mean? If it's not greater than 1, it means it's not any of these answers here. Can it be 1? Well, yeah, it can. It just can't be greater. So we circle that because it can be 1. And then we 0, negative 1, negative 2, negative 3. These are the answers. Whoops, that's a 2. These are the answers. It can be solid circles here because it says integers, counting numbers. So I'm looking for all the numbers that are not bigger than 1. That means they're either 1 or less than 1. So it's going to be numbers that go that way, and it's the counting numbers. So that's letter B in your practice problems. And the last part of this lesson is spheres. Spheres are basically a ball, and they have a volume, and the volume of a sphere is 4/3 pi r cubed, and r is the radius. So 91.4, they give you a radius of 3. So we're going to put in the numbers first. There's the radius, and we're going to cube it. So v equals 4. And I'm going to put the pi at the end so that I can put that closest to 4/3 because I can combine those. 3 times 3 is 9 times 3 is 27. And this is 27 over 1, so if you remember, you can cancel this one with that, and then you've got 36 pi for an answer. And I'm happy with 36 pi for an answer. If you want to keep going, multiply by 3.14, and you end up getting 113.04. And it's in centimeters, so it would be centimeters cubed. It would be the unit of measure ending that. So probably the key thing is this right here. You could have taken the 4/3 times 27, and then taken 4 times 27, divide it by 3, and you would get your 36. But I saw that I had a 3 there and a 27, and I knew 9 went into both of them, so I could cancel. Or 3 goes into both of them, so 3 goes into 3 once, 3 goes into 27, 9, and that just reduced it before I actually even did the problem. It just makes life easier. Okay, let's look at the next one. The next one is based on a formula called the surface area of the sphere, and the surface area would be, if we've got a basketball, how much material would it take to make a basketball? That would be the surface area. And surface area then would be 4 pi r squared. So example 91.5 says, find the surface area of the sphere whose radius is 4. So again, all we're doing is plugging 4 pi, radius is 4, squared. So 4 pi times 16. 16 times 4 is 64. And then multiply 64 by 3.14. Now we get 200.96. And because this is an area, it's going to be squared. And that's what you get for an answer. And that's it for problem set number 91.